explore the key components of the Bioflow 110 reactor. Dissolved oxygen probe. The DO2 probe is used to measure dissolved oxygen in the fermentation broth. Sampling device is used to draw samples of fermentation from the bioreactor. Filter exhaust air. All exhaust air passes through a 0.22 micron filter to prevent the fermenting microbes from escaping into the environment. Airflow meter. The airflow rate sparged into the bioreactor is set by this meter. Jacket water inlet. Cold water enters the bioreactor through the jacket water inlet located at the bottom of the glass jacket. Temperature sensor. Temperature of the broth is measured with a probe that is inserted into a well. Jacket water heater. This component is located at the base of the bioreactor and heats the water that is circulating through the glass jacket. Water regulator and pressure gauge. This assembly is used to adjust the entering water pressure to within the rated pressure range of the glass jacket. pH probe. A pH probe is used to measure the pH of the fermentation broth. Filter inlet air. Air is filtered through a 0.22 micron filter to sterilize the air that is sparged into the broth. Agitator. The agitator ensures proper mixing and aeration in the fermentation broth. Base pump pH. The base pump is controlled to deliver a base solution to the bioreactor to maintain the pH at a specific value. Jacket water outlet. This overflow drain tube is located in the glass jacket, allowing the jacket to completely fill the water. Excess water is drained through tubing that is discharged in the sink. Inoculation septum. The inoculation septum is a membrane that allows for the sterile injection of microbes or chemicals in the bioreactor by using a needle syringe. Air cylinder. The air cylinder is a large canister of compressed air that supplies air oxygen at a regulated pressure to the bioreactor. Stir bar. A stir bar present in the base of the jacket helps keep the jacket temperature uniform. Next, the common operations of the Bioflow 110 reactor. The first process is to calibrate the dissolved oxygen probe. Step 1. Confirm that the air cylinder is open and air is sparging into the bioreactor before you begin. Select the DO2 key on the primary control unit PCU touchpad. Step 3. Select Calibrate on the PCU. This will take you to the Calibrate menu. Select Set 0 on the PCU touchpad to begin the calibration process. Step 5. Enter the number 0 on the PCU touchpad. Step 6. Important. Before you press enter, you will need to disconnect the DO2 probe and wait until the raw input value stabilizes. Step 7. After the raw input value has stabilized, press enter to accept your set 0 value. Step 8. You may now reconnect the DO2 probe, then select set span to continue with calibration. Step 9, which is to enter the number 100 on the PCU touchpad. Step 10. After the raw input value stabilizes, hit the enter key. Step 11. Select Return to Main on the PCU touchpad to finish the DO2 calibration activity. Step 12. You have now calibrated the DO2 probe. Process 2 is to set a specific water temperature using setpoint. Step 1. Select the temperature key on the primary control unit PCU touchpad. Select the setpoint on the PCU. This will take you to the setpoint menu. Step 3. Enter 35 degrees Celsius on the PCU touchpad. Step 4. Select Enter to accept the new value. Step 5. Select Return to go back to the PCU main menu. Step 6. You have now completed the setpoint activity. The third process is to taking a sample with the Bioflow 110 reactor. Step 1. Open the thumb clamp on the sample intake tubing. Step 2 is to pull on the syringe plunger to create a vacuum in the sample bottle. Step 3. Fill the sample bottle to within 25% and 50% full. Step 4. Pinch close the thumb clamp. Step 5. Remove the sample bottle by rotating counterclockwise. Step 6. Transfer the sample and replace the bottle. Step 7. Unscrew the syringe before depressing the plunger valve. Step 8. Depress the plunger into the syringe to prepare for the next sample. Step 9. Reconnect the syringe to the air filter. Step 10. Reconnect the syringe to the air filter. Step 11. You have completed the activity of taking a sample. Process 4 is airflow within the bioreactor. Step 1. Air for the bioreactor is delivered from the pressurized air cylinder to the airflow meter. The fermenter requires the oxygen that is in the air. Step 2. Adjust the incoming airflow rate using the airflow meter. Step 3. Air is then passed through the filter to sterilize the air before entering the bioreactor. Step 4. Sterile air enters the bioreactor through the spudger tube and is released as air bubbles. Step 5. Air exits through the exhaust air filter to contain the microorganisms within the bioreactor. Step 6. You have now completed the airflow activity. Process 5 is the temperature control within the Bioflow 110 reactor. Step 1. When the temperature of the bioreactor is above the set point, cooling water is added through the jacket by means of solenoid valve. Step 2. When the temperature is below the set point, the jacket water heater comes on to heat the jacket water. Step 3. Cold water comes from the faucet through a water regulator and pressure gauge to adjust the line pressure to a safe range. Step 4. The cold water travels through tubing to the solenoid valve. Step 5. The solenoid valve will open to control the flow of water to the bioreactor based on the target set point. Step 6. Cold water travels to the jacket water inlet on the bioreactor. Step 7. Cold water enters through the jacket water inlet. Step 8. On the jacket is filled. Excess water is expelled through the jacket water outlet. Step 9. The water is then discharged through the tubing to the sink. Step 10. To increase water temperature, select Temp on the PCU menu and press Enter. Step 11. Select Setpoint on the PCU. This will take you to the Setpoint menu. Step 12. Select a setpoint higher than the current temperature of 36.1 degrees Celsius and press Enter. Step 13. The jacket water heater will activate until the target set point has been reached. Step 14. You have now completed the temperature control system activity. Next, done.